Hello and welcome back. This is lesson 2 in basic logic gates for electricians, where we're going to use ladder logic to explain the function of the exclusive OR and the exclusive NOR gates. If you haven't seen part 1, I encourage you to go back there and check that out first and then come back. So, with that being said, let's get started. As I stated before in this video, we're going to take a look at the exclusive OR gate, the exclusive NOR gate, and similar to the last video, we're going to look at the truth tables associated with them, and we'll be using ladder logic to explain the functionality of each of the gates. With that being said, let's get started. Here we have the symbol for the exclusive OR gate. It is similar to the OR gate, but it has an extra bar on the input side of the A and the B, or the left-hand side, to let you know that it has a slightly different function from the OR gate. Here we have the ladder logic for the exclusive OR function. The AND function was a series wiring. The OR function was a parallel. The exclusive gates are a series parallel combination, as you can see here, where A and B are sort of wired in series, but also sort of wired in parallel. So if we look at the logic through the truth table and look at the ladder logic in the diagram, when I don't press A, as well as I don't press B, you can see that A keeps line 1 open, not allowing current to go through and energize my coil. And button B keeps line 2 open, not allowing me to energize coil M and close M contacts, turning on my yellow pilot light. So, if I don't have A and I don't have B, I don't have an output. If I should press button B, B will open up line 1. Now I have 2 opens on line 1, but B closes line 2, which allows current to go through line 2, energize coil M, which will close the armature on the M contacts, turning on my yellow pilot light. Also, if I should push button A, I will now close line 1, energizing the coil, pulling in the armature, closing the contacts M, and turning on my yellow light. However, if I should push both A and B, A will close line 1, but B will open line 1. B will close line 2, but A will open line 2, thus not allowing any current to get to my M coil, not allowing the armature to pull in, and not close M contacts. So that's where it becomes exclusively A or exclusively B, but not both. That's the exclusivity of the exclusive OR gate. It becomes very practical and very handy when you want only a single condition to happen, but not multiple conditions to happen at the same time. One application of the exclusive OR gate is when you want to turn lights on or off from multiple locations, such as a push button controlled by a PLC, where when you enter a room you push a button and the lights will come on, and if you leave a different door and press a different button when you press it, then the lights will go off. And if you should, for whatever reason, come in a different door, well, then you can turn the lights on again as you enter the room. So the exclusive gates are quite useful when you want to turn stuff on or off from multiple locations. Now before we jump into the exclusive NOR gate, let's quickly review the inverter or the NOT symbol or the NOT gate. Here, when I don't press the button, my contacts are now a normally closed set of contacts on the second line. So that as long as my coil isn't energized, my contacts are closed. In this case, my pilot light is on. So when I don't have input A, I do have a light on. But should I press button A, well then my M coil gets energized, pulls in the armature, which opens up the M contacts, turning my light off. Therefore, when I have A not, I do have output Y. But when I do have A, I do not have output Y. And that's again how the inverter works. It acts like a set of normally closed contacts. Now let's take our exclusive OR gate and we'll add to the output an inverter, so that I now have exclusively A or exclusively B inverted, or exclusively A or exclusively B not, which gives us our knotted exclusive OR gate, in this case the exclusive NOR gate. And just like before, instead of redrawing the whole inverter on the output of the gate, all we do is we take the inversion bubble off the inverter and place it on the end output of the gate to let us know that the gate has been knotted or inverted. So now let's take a look at our knotted exclusive OR gate, or our XNOR, or exclusive NOR gate. Here's the relay logic. And again, you can see in line 3, all we did was change out our normally open contacts for a set of normally closed contacts, so that current can flow through line 1 down to line 3 through the normally closed contacts, and the yellow pilot light is on even though we don't have any inputs A and B activated. So line 1, A is open, so no current can get through. In line 2, B is open, so no current can get through. My M coil is not energized. My armature is not pulled over, so my closed contacts on line 3 are closed and current can get through, illuminating my yellow pilot light. If I should press input B, I will close line 2, but open line 1, and allow current to flow through line 2, energizing my coil, activating my armature, and opening up the closed contacts, turning my light off on line 3. Also, if I should press button A, I'll close line 1, allowing current to flow through, energizing my coil, activating my armature, and opening up my contacts in line 3, and turning my light off. If I should press both A and B, well, A closes line 1, but B opens line 1. B closes line 2, but A opens line 2, not allowing any current to get to my coil, thusly no armature action, and so my contacts remain closed on line 3, and my light is on. The exclusive NOR gate is really useful when you want two of the same condition, but not any alternate conditions. One example I can think of is if you have multiple hatches. You want all the hatches to either be open to give you a light to let you know they're all open, or all the hatches are sealed and closed, and therefore you got another warning light to let you know they're all closed. But you don't want them either opened or closed. Either all open for safety, all closed for sealing, or vice versa. But you don't want any conditions where there randomly may be some open and some closed. So you're exclusively not A or exclusively not B, but you can be both A, B, or not both A and B. So now we have all of our gates. We have the AND gate and the OR gate and our exclusive OR gate. These are our three primary gates. We then introduce the inverter or the NOT gate. And from the AND gate through the inverter, we introduce the NAND gate. The OR gate Inverted will give us a NOR gate. The exclusive OR gate will give us a knotted exclusive OR or the exclusive NOR gate. Well, I hope this helped. I hope you now have a better understanding of logic gates, how they can relate to ladder logic. And from here on in, you can start using that reasoning and rationale to help you start programming using logic gates and function block programming. Good luck to you, and see you in the next one.